The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Alright, so now I'm going to work through problem number 4, and for Physics 2020 Midterm Exam 2, year 2006. And if you look at this problem, it says it's a continuation of problem 3. And so if you haven't done problem 3, it's probably a good idea to work through that problem before you get to problem number 4. And so basically in problem number 4 is asking us, what is the angular speed of the wheel 4 seconds after starting from rest? And remember, you had to refer to a wheel. Okay, the figure had the wheel where we had a force applied to it acting at a perpendicular distance from a radius of 0.1 meters. Okay, so we're rotating this wheel. This wheel has a radius of 0.1 meters, and in problem number 3 we were asked to find the angular acceleration. In this problem, it's asking us to find the angular speed 4 seconds after the wheel starting from rest. Okay, so we know that rotational motion is analogous to translational motion, and in translational motion we would be talking about acceleration would equal to your change in velocity over the change in time. So this would be for translational motion. Okay? But since we're talking about rotational motion, we don't talk about A, we talk about alpha, which is angular acceleration, and instead of velocity we talk about angular velocity, which is the change in omega and over the change in time. Okay? So we know that the change in velocity is defined as the final velocity minus the initial velocity over the final time minus the initial time. And we know from the problem statement, we know that if we're starting from rest, that we're starting at time 0, and we know that the initial velocity is 0. Okay? And so we know that this equation then reduces to just your final velocity divided by your time. And in this particular equation, we know all the information. If we use the information that we got from problem number 3, we know the angular acceleration, and we know the time that's given in this problem. We can solve for the angular velocity. So rearranging this equation, we get angular velocity, or the speed, is equal to your acceleration multiplied by your time. Okay, so we can just go ahead and substitute in the information. We know that the angular acceleration is 0.17 radians per second. Okay, and we know that the time is seconds squared, and we know that the time is 4 seconds, so that one of those seconds cancels out and that'll cancel out, and what we're left with actually is radians per second, which is a velocity, angular velocity. And when we work this out, our angular velocity is equal to 0.68 radians per second. And that's the solution.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.